my first lecture. Before to start lecture, I would like to tell you that now all sections should be separately, and all instructor of the section give the lecture themselves. Therefore, look on timetable that everything we do according timetable. Also, it should be one per week should be one interactive session, which is I announced before. Now I will start my lecture. That means in the three first lectures, which is you received online by video, this lecture was given by the Dr. Tayyab. It is concerning application of the one-dimensional integrals for calculation of volumes, surface of the body, revolution of body, and revolving body, and also calculation length of arcs. Now, application works, how to calculate the works, and also some forces. Let us now, I will consider as a problem, which is also very important. It is concerning the momentum. That means the momentum used in not only in the mathematics, but it is used in many areas of the sciences and also in civil engineering. For example, that means if you take in the mechanics, you studied, I think, torque. In this case, it is very important where apply the force, in which point apply the force, and where is and what will be torque of this force, because the torque in this case equal to product, the cross product of the arms to the exert force. The other problem, it is electricity, that there is a dipole moment, also magnetic moment. So there is an application also in the mathematical statistics. So we begin to consider very simple case when we define for one particles, then two particles, then many particles, and then some solid. How possible to define moment? What means that how we define the center of mass, which is sometimes it is called, if the mass on the body distributed uniformly, it is called centroid. That means the title of my first lecture is the following: that momentum and center of mass. Let us, I will consider one particles. That means that when I talk in a particle, that this is, we neglect by this size. The mass of this particle should be m. Well, that means, let us here, I will take the origin. This is the point of origin. I will take the axis of such that it is this axis passed from this body. This will be equal to coordinate x. Because one particle, therefore enough one coordinate. Okay, the position of these particles defined by coordinate x. So, respect to this origin, we define the momentum like following. That means the momentum m should be equal to here m times x. where the m is the mass of this particle, x its coordinates. Well, why it is so important? Let us consider one examples. That now I will consider other examples. Here's the origin. Now we have the two particles on this x. One particle, here's the m1. Here's the particle m2. The coordinate, here's the x. Coordinate here will be x1. Here's the coordinate x2. That means we have the system of the two particles. How to write now the momentum for this system of the two particles relative to the origin? That means the m should be equal to m1. m1, this momentum for first particles, plus m2, moments for second particles. So, according to these definitions, we can write will be m1 x1 plus m2 x3. X2, sorry. X2. If you have the system of the particles here, that means which is lie on the one the same on the one line. That means in this case total momentum should be equal to m1 x1 plus m2 x2 plus m3 x3 plus and so on. Or shortly, using the sign symbol, sum from from 1 to n, here will be m I to x I. This is the momentum for this case. Why it is important? Let us consider one physical problems. That means I have, for example, two particles, which is on the very thin stick. That means this is a stick. The mass of the first particle m1, for second m2. This is a stick. That means let us, I will put here that I will decide that this is point origin, and here there is supported by fulcrum. That means that this is a fulcrum. And for this system act some force, which is we call the gravitation force. That means the gravitation force has in this direction. That means a G. This is a G. G will be the same, of course, and that means the force, first one force, which is exact, will be product mass 1 to G. For second one, act the force equal to M2 G. Okay, that means if support here, you see this system should be not will be stable. Why? Because above, that means this under action this force appears the torque, and torque have the same direction. That is, it has a counterclockwise directions. Therefore, it will be not stable, this system. Now, I will consider following very simple case. I will take now the same. Here's a mass m, and here's a mass also m. That means the force which is act to these bodies the same. Now I will take the support. That means this is a stick. I will take which is a massless and very thin. That means this here is the support. Of course, in this case, because due to the torque, it is begin to move counterclockwise directions. Now I put here support. That means that I changed the position of the support. Now it is here. You see, also will be not is not will be stable. Why? Because here the arm of this force respect to this point smaller, arm here the larger. Therefore, it is again the system will be rotated on this. It is clear for you because the mass mass 1 and mass M2 equal to each other. If I will take the support here in the center, that means that when I will see this position, this is the center, which is the center. In this case, this will be stable. Because here, you see, I will tell you again that this is a massless stick, therefore it is not force will be equal to, which is act to the stick, equal to 0. So this system will be that. This is called the center of mass for these two equal particles. If the mass will be different, that means that here there will be M1, M2, and the point where it is necessary to support it by fulcrum, it is depend on mass. If the mass will be larger than M2, that means that you put here, closer to M1. If the M2 will be larger than M1, it will be closer to M2. It is clear from physics. Well, but it is necessary to define what will be exact positions. How to define exact position? I know that they will be closer, but it is necessary to find close position. For this, I will calculate it moment by following. That means here I will take the origin. Here's the line. Here's a mass 1. Here mass 2. Let us guess where should be this support. That means support should be here. And this system will be stable. That in this coordinate of this fulcrum x, here's the coordinate of this particle x1. Here there will be x2. X2. Okay, that means I now instead of calculate the momentum these particles respect to origin, I calculate respect to this one because this is a fulcrum have the position so that this and these particles under gravitation force will be in the stable. Therefore, that means we can write the following. That means M1 here will be G. The coordinate, the position of this particle respect to this point will be x1 minus x bar coordinate of the fulcrum plus M2 G x 2 minus x bar equal to 0 because it is equilibrium. So now we will find from this what will be x bar. That means here possible to count, that means delete the G because it is the same, because this side is 0. So I can write the following relation. M1 plus M2, M1 multiplied to this one, M2 multiplied to this one, equal to x. I change the sign. This is also when this M1 multiplied to x1 plus M2 multiplied to x2, I move to right side. It will be opposite sign because I changed here sign. Also changes, and this side also change the sign. Therefore, this will be M1 x1 plus M2 x2. From here, I receive here's x bar. X bar should be equal to m1 x1 plus m2 x2 over m1 plus m2. That means this is find the position of where it is supported, that it is which is called center of mass. Is defined, find it, the center of mass that would now we extend this relation for system of the particles, which is lie on the one line. Therefore, this case possible, that means also possible to take such position when we have the many particles. That means you have the system of the particle which is lies on line. That means here's a take origin. Oh, here's the coordinate. Here's the m1. Coordinate x1, here's m2, coordinate x2, m3, coordinate x3, and so on. So that means it is possible to find such positions support where, if that is connected by the massless stick, that the system will be in the stable positions. Therefore, that means m1 x1 minus x, here's the coordinate of this one, x bar, x, plus m2 x2 minus x bar, plus m3 x3 minus x bar, plus and so on, equal to 0. So from here, like we find this one, we can write, that means x bar should be equal to m1 x1 plus m2 x2 plus and so on, divided to m1 m2 m3 plus and so on, which is possible to rewrite in more reliable form. That means the sum from k to n m k x k divided to sum from k to n, here's m k. This is a total mass. That means this is possible to write. This is should be total mass. So this defines the coordinate for system of the particle, which is lies on the one line. That sometimes it is necessary to find the not one-dimensional case. That because here we use it one coordinate. Let us we consider when particles placed on the plane. How to find in this case center of mass? That means I will take 3 particles. That means m1, here m2, and here m3. That means that we have this position. So it is necessary to take the again origin for calculations momentum of all these particles. That means that now I will take the origin. This is the origin and coordinate x. This and here will be y coordinate. Here's the y. That means now instead of one axis we have the 2 axes. So in this coordinate system, this particle has the two coordinates, x coordinate and y coordinate. Let us to write this coordinate. That means the x1, y1. Second should be has the coordinate x2, y2. Third has the coordinate x3, y3. Now separately we define the, because the now moment should be defined by following. That means respect to this axis and respect to this axis. That means if I will define the respect to y-axis, that means y, I will write this my should be equal m1 to multiply to x coordinate, because I will take the arms, that means the coordinate will be this one. Therefore, that means the total momentum of this system respect to y-axis should be equal to m1 to x1 plus m2 x2 plus m3 x3. Respect to x-axis, mx should be equal to 1 m1 y1 plus m2 y2 plus m3 y3. Okay, that means that if we find such point, that means I will find the new coordinate, for example here, that the system of this, if the that it is connected by the some sticks, massless sticks, that and here will be some support, which is act. In this case, the system will be in equilibrium. That means that therefore that if I will find the now new respect to this coordinate, that means m y prime should be equal to what? Here will be m1 x1 minus x bar plus m2 x2 minus x bar plus m3 x3 minus x bar. And because this is a system in the equilibrium, therefore should be equal to 0. And m prime x should be momentum depend on the distance, of course, therefore this momentum and this momentum, or this and this will be differ. That means that here there will be m1 y1 minus y bar plus m2 y2 minus y bar and plus m3 x y3 minus y bar equal to 0. That again repeated the previous manipulations, because this side is 0. I will write the coordinate of the center of mass. That means that we will find the coordinate of center of mass. That means the x bar should be equal to m1 x1 plus m2 x2 plus m3 x3 divided to m1 plus m2 plus m3. And y coordinate should be equal to m1 x1 plus, y1 m2 y2 plus m3 y3 divided to m1 plus m2 plus m3. This is a 3. This is the center of mass of this system. if we have the n particles, if we have the n particles, in this case will be the following equations. That means the center of mass, defined as the sum. Here the k from 1 to n. Here there will be mk to xk, and divided to total mass of the system. K1 to n, here the mk. And y coordinate of center of mass will be sum mk to xk, yk divided to, here the k from 1 to n, sum k from 1 to n, mk. This is a for system of the particles, which is placed, that means placed on the plane. How that means for it is extended these equations to for the following case, when we have system of the masses, which is placed, changed uniformly. That means solid. Let us initially, I will consider the following case, when we have the, again I will, this is a, here's a line, here's a mass distributed uniformly. Here's a, I will take the origin. Okay, origin possible to take very in this case in any point. That means I will take here, but line and origin lies on the same line. That means that here's a coordinate x. That means here's the initial point A, here's the final point B of this. That means we have there some heavy, some stick. Well, how to find now the center of mass? Let us assume, that means we know, if you know that again, if the mass here distributed uniformly, the center of mass of system, possible to tell that will be exactly in the midpoint of this stick. If the mass will be different, distributed, that means it will be density of density. If they change it, in this case, it is necessary to know. But for this case, possible to make the following. That means when in this case I divided this for many some small masses, small masses. That means that this is, for example, here I will take that this is will be dm, mass dm. Its coordinate of this should be x. dm. That means now you see now if I will, because this is dm, let us initially I will write is a delta m. That means that this is the delta m. Delta mk, coordinate xk. That means now respect to this point, the momentum of this stick should be, it is necessary to make summation of the momentum of these very small masses. So m should be equal to sum here the over all this from I from 1 to n, and here will be delta, that means xk, xk times 2 delta m k.
The marker was...
Okay, thank you. xk and sorry, that means will be sum. Here there will be delta m k, k from 1 to n, delta xk, according to this equation, which is we wrote like this. Because it is the mass distributed continuously, therefore it is necessary to make this is a smaller and smaller. The number of these masses, very small masses, go to infinity. That means in this case we receive following m. M will be equal to limit when delta x go to 0. That means the n go to infinity. Sum k from 1 to n, and here should be delta mk to xk. Because this limit, it is the same as the Riemann sum, we receive the following result. That means instead of summation should be integrals. That means we receive that m should be equal integral from this end to this end. From a to b, here will be x to dm. That means this is a for line distributed mass. The same if we have the distributions for solid. That means that means we have the sum this plate, right? That means for this case. In this case, that means because there are two coordinates. Here's the y coordinate. Here's the x coordinate. Let us. I will take the coordinate not related to the body. I will take this one. Here's the x, here's the y coordinate. So in this case, we make should be two components. That means my will be integral. I will note here the coordinate of this. That means according to these equations, that means there will be integrals. Now it is should be written as the x, here's it to dm, because now m will be more complicated. Mx should be integral y to dm. And how do you find now? Because we know that it is if we change the position of the coordinate, that means I will find such point that this momentum and this momentum should be moment will be equal to 0. That means in this case x bar, that means the center of mass coordinate for this case, will be integrals. Here there will be x to dm divided integral to dm. This is the total mass. And y bar will be equal to integral y to dm divided to total dm. That means it is only extensions, summations, because the summation here will be Riemann sum. Therefore, we replace it by the coordinates. Let us now we solve some examples. When simple examples, because in general case very difficult to calculate this type of the integrals, but in the simple case possible to find. What's the idea? Initially, I would like to find what will be. I show you that if you have the some segment which has the mass, that means like this. Here, which is the length L, that means here's the coordinate A, here's the coordinate B, here's the origin O. That means we know if the for I will take the mass, it is distributed not uniformly. Therefore, if you take the sum dm, here's the dm, here you will take, here the, should be coordinate x, dm, that mass dm should be equal to density. Let us to take the density of body, because here the linear distribution of mass, therefore will be dx, equal to dx. That means the dm, thickness, dx. Then position of coordinate x, that means therefore momentum should be equal to what? Rho, it is a function of x. Let us, I will write. That means for that this is a function of x. Here's the dx. Here, that means the m will be equal to integrals from a to b, and here will be x to dm. Now I change this to a dm. I will write this. B, here will be x, here will be rho to dx. That means that I receive the following, because I will rewrite this as from a to b. Here will be rho, which is a function of x to dx. If you know distribution of these masses, in this case, you can find if the total mass of this, I will write by some m, the total mass of the system. Total mass should be equal to integrals from a to b. Here will be rho x to dx. This is total mass. Total mass. So the x should be equal integral from a to b. Here will be rho x times x to dx divided to integral rho x to dx, and from a to b. Okay, that means this is in general. That means that if you know what the functions describe the density, in this case possible to calculate this integral. Very simple case when is rho is constant. Rho is constant. In this case I receive x. Should be here the r constant possible to remove. Therefore integral from a to b. Here will be rho, and here will be should be equal to x to dx, and over. Here's the integral rho. Here's the integral from a to b dx. What we receive? This is integral known. That means you see rho cancelled. That means it doesn't depend. In this case, doesn't depend on the materials from which constructed this stick. That and the coordinate should be the same. That means this integral very simple. That means x squared by 2 from a to b, and divided here will be equal to b minus a. That means b minus a. Let us to simplify. That means that here there will be 1 by 2. Here will be b squared minus a squared divided to b minus a. Minus a. That means this is, let us we simplify. Here will be, if you write, this is should be 1 by 2. Here b plus a, b minus a divided to b minus a. b1 at this is cancelled. That means that we receive 1 by 2 b minus b plus a. B plus a. That means the b plus a. That means that if you take this sum, b, that means this distance plus distance and divided by 2, exactly you receive the center of mass. This will be in the center of the stick. You see, we receive 1 by 2 equal to b plus a divided by 2. Because b Uh, sorry. Yeah, yeah, all right. That means exactly here. We receive this result. If that depend on the mass, in this case, there will be problems. If the rho depend on coordinate, it is necessary to know that. Let us, I will consider other examples. The idea when you have the plate, some plate, in this case, sometimes it is, in general case, it is necessary to calculate two-dimensional integral. It is not reduced to one-dimensional. Let us consider these examples. Thin, flat plate. That means we have the following questions. That means the exercise, example 1. That means the triangle plate shown on figure 6.48 has a constant density of, here the rho equal 3 gram centimeter square. This is you see, this is not linear density. This is a surface density. That means find the plate's momentum my about the y-axis, the plate mass of m, and x coordinate of the plate center of mass. That means the center of mass. Where is the center of mass? That means the following picture. This is a y. Here x. That means we have triangle. This end has a y coordinate equal to 2. Here's a 1. Here's the origin. That means this is origin. Okay. You see origin in this end of this plate. This is, we have this plate. How to calculate in this case? Now we have the two-dimensional distribution of the masses, not one-dimensional on the line. But this type of equation also reduced for one-dimensionals by following way. That means let us we separate this for many some strips. That means we divided for many like these strips. Which is have the very small thickness, dx. That means that for every this strip, I know how to find the center of my, because it is thickness very small, wave should be a center. Center should be here. Center of mass. Of this one should be here. This should be here. Here, 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 and so on. Sorry, here should be like this. Therefore, this will be here, here, in the center. Because you know, if you have the uniform some strip, center of mass will be here. This will be x tilde. I will write the x tilde. This is center of mass. Therefore, center of mass of this here. That means that instead of, that means because it is possible to find the, for all these strips, where is the center of mass, the coordinate of this will be x delta. That means that here it is coordinate of x will be the same for all this line. That means all the masses of this strip, I will decide that is here mass should be dm. This will be mass dm. dm tilde. Okay, dm. So then now I will decide that all these masses of this strip concentrate in the center of mass. Of these ones concentrated here, and so on. That means I receive this line. This line you see by height twice less. Twice less. That means this is a line will be, if this is a line equal to y equal to 2x, this y tilde should be equal to x. That means instead of to consider now for because to consider two-dimensional case, I reduce it to one-dimensionals like this. Therefore, that means the center of mass. Because of course the dm will be different for this state because this is height larger, therefore the dm will be other larger than others. See, here will be at last here the 0. So let us now write the integrals. That means if we write the integrals, m y should be equal integral the coordinate x tilde, coordinate of that coordinate of this point. Here integration for should be from 0 to 1, from 0 to 1. Here multiply to dm delta. So that means let us to find what will be dm delta. dm tilde should be equal to coordinate, because here this it is necessary to take the mass of this plate. So dm should be equal to delta multiply to this area of this one. Area, that means d delta a, which is because delta a, because here you see this is a 3, sorry, not delta rho, because I use it rho letter. This is should be equal to rho. Rho. Here's a dA, that means a rho 3, multiply. Here's multiply to dA, to mass. That means it is necessary to dx multiply to coordinate. That means that this is height equal to 2x. That means multiply 2x and dx. Because that's 2x to dx, it will give us, for example, I will take this strip. That means because here it is necessary to multiply, this is dx, this is height equal to 2x. That means we receive this. That means this will be 6 x to dx. Now I substitute to this equation. Y should be equal integral from the 0 to 1, and here will be x times 6x to dx, or this will be in 6 integral from 0 to 1. Here's the x square dx. We calculate these integrals. This integral will be x cubed divided by 2. That means 6 x cubed divided by 3 from 0 to 1, which is give us we receive the answer 2 by 3. Oh, sorry, here's a 2 2, because the x from 0 here is 0, 0, that means that this is 1, should be 2. M equal to 3. Well, now coordinate. That means x coordinate. It is a my divided to total mass. To total mass, that means a 2m. Total mass of the plate, that means should be equal to 3g. Total mass, because it is necessary to area multiplied to this one. Because m equal to area, that means m y divided here there will be rho to multiply to area. Area should be 1 by 2. This side multiplied to this side. This 1, here is a 2. Therefore will be 1. That means the area equal to 1. So I have the following result. That means a 2 by 3. By 3. This is a position. Because if this is in the centimeter, here if the coordinate is centimeter, that means the result will be centimeter. That means that all this type of the equations always reduce it. That means that 2 dimension, when you have the plate, in this case it is necessary to reduce to one-dimensional integral. It is possible to make only in the simple case when you know distribution. These examples you will find in the book. Give some examples. You can see this type of the solution and solve the exercises. That's all for today.